Hello, brief calculus students. Welcome to Indefinite Integrals. Basically, we're just trying to undo derivatives, and we use this little curly symbol. We call it the integration sign, or integral sign. And so I just pick two derivatives. We've got an f function and a g function. And here's the derivative, right here, 6x plus 2. So to take the antiderivative, we just take the integral of 6x plus 2, and then we add on this dx to show that the variable really is x. Well, what is the antiderivative of 6x plus 2? Is it f? Is it g? We're not sure. They both have the same derivative, so we just say, okay, we're just going to make sure there's a constant at the end. So the basic rules. Power, always your favorite one with taking the derivative. You move the n down, you subtract 1. Well, integral, we undo that. We add 1, and then we divide by the power. So instead of multiply by the power, we divide by the power. And since it's the opposite order, we add the 1 first, and then we have to divide by that. So that's why there's a plus 1 in this. So make sure that they are the same right here. If there's a constant out in front, it comes along for the ride. If there's a constant with the integral, it just comes along for the ride. Just tags along, and you can either leave it out in front or simplify it. If there's just a constant derivative, well, we have this variable right here, this x. So that's why when we do this, we're trying to integrate a constant. We say, okay, what was the variable? Now let's multiply by that variable. So we want to integrate 2 dx. We just say that's 2x, and then don't forget that plus c. If we're adding or subtracting, we just add or subtract derivatives. You can go through and work that out. Same thing with integration. You just add or subtract each individual piece. And you can get as crazy as you want. Just don't forget your c. If you have an exponent, well, remember we had to take the natural log of the base of the exponential function. So here's a finance program or problem. I use t for time. And there's that natural log right there. Well, when we integrate, instead of multiply by a natural log, we're going to divide by it. So it comes out really good. Now, what happens if you have e right here? Well, remember, e was special. We don't have to worry about natural log. It's just, boom, there we go. It doesn't matter if there's a constant in front. It's just itself. So when we integrate e to the t dt, well, it becomes e to the t, and then don't forget that c. It's still going to be there. By definition, when we had a natural log in the function, when we took its derivative, it became 1 over x. And x had to be greater than 0. Otherwise, natural log didn't exist. Well, when we integrate, we're going to start with this 1 over x, and then it becomes the natural log. And the absolute value is really important because x has to be greater than 0 for a natural log function. And again, it can't be equal to 0, or this function doesn't even exist. Okay, so 6 over x is the same as 6 times 1 over x. So that's 6 times the natural log of x, and then our plus c. So here's some crazy function that puts it all together. Alright, so we've got our constant, our power, our sum, our difference, our exponential function, and our natural log? Yeah, natural log is hiding in here with this 1 over or x to the negative 1. You need to be able to recognize that that's the same. So when you take its derivative, you can walk through all this. And I simplified it. And so here is the antiderivative, or the integration of this crazy function right up here.